Okay, so welcome to this presentation about how to contribute to OpenEmbedded to Yocto project and actually to many other open source projects. So this actually comes from just a sec, yeah, from I just want to start a timer so that good. This starts from an effort we've made in mostly in August and September. We wanted to have a contributor guide to be added to the documentation. I like to consolidate all the guidelines we had in README files and also in wiki pages that were scattered and people could modify without other people noticing. So that was a good idea. So the contributor guide is here, as you can see on the screen. And in the process, I learned new Git tricks. Also, I did my own that were not written in the wiki pages. I hope you learned some new things as I did, right? So the goals of this presentation is really to how to guide people to contribute code to many projects like not only OpenEmbedded and the Yocto project, but also Linux, U-Boot, BusyBox, GNU, and Git, and so many other projects. So here, my goal is not to focus on the specifics to OE and the Yocto project because they are written in the contributed guide. I would rather like to focus on what's generic, like what the common guidelines that apply to most projects, especially the ones who have reviews and patch submissions through mailing lists, right? And anyway, if you contribute to Linux, to U-Boot, to BusyBox, that's going to end up built by the Yocto project. So it's good for us as well, in any case. So the first thing we had to cover, and that's a very frequently asked question, is why we ask people to contribute through mailing lists. And well, there are various advantages versus the web-based workflows that seem more natural to some people, because you have more eyes reviewing the changes, because the changes are sent to mailing lists, so anyone can have a look, even people who didn't sign up as being reviewers. And we think it's more more eyes compared to workflows that are set to be processed by a number of registered individuals, and only those people. Another thing is it's possible to comment on specific parts of the change as you would reply to an email. That's very convenient in our opinion. And that's a workflow that has worked for so many people in the community, like people who have been around for quite a long time. We are familiar with that, so we need to keep this way, because otherwise we may lose contributors if we move away from that. And anyway, it's not like it's a completely manual process. We also have tools to automate this, so that's like not completely manual in the mailbox. We have Patchwork that's set up for Yocto project, for example, which you can use to track all the submitted patches to a mailing list. And we now have patch testing tools for screening the typical mistakes and reduce the load on the reviewers, for example. So let's go step by step what you can do to what you should do we expect you to do to contribute something to the Yocto project or to other projects. So the first thing, of course, is to install Git. That's the Ubuntu example. You also need to set your name and email address, because we expect you to sign your commits, and that's why we need the name. Then prepare your repository. So you found something to change, to improve, to fix. In one of the repositories, you found the source, or the corresponding repository. So you clone the repository, and then typically what you're going to do is check out the branch you want to modify and create a new branch for each set of changes. That's quite important. One branch per set of changes, right? And make sure you keep unrelated changes in different branches, of course. Don't mix them up. That will make things easier to work on. And then you can go ahead and implement your changes in your branch. Once again, only the related changes at a time. And make sure you test them well enough. Yes, it's quite important. Don't rush too much and submit patches too quickly, because you would end up, hurting your reputation as a good source of good fixes, let's say. So yeah, that would be embarrassing anyway if people figure out you didn't test your changes ahead of time. And then group your changes in one branch. The major rule here is one commit per change. Commits should be atomic, like they shouldn't be grouped to two unrelated things. So you should be able to split them into, you shouldn't be able to split them, right? Or of course be reasonable. And all this makes it easier to review and accept changes. Subcommit may be accepted in the first submission, and some may need further work and may need a V2, right? Of course, there's a counter rule here. You could group changes of the same kind that apply to different files. Don't be too extreme. If they have the same maintainers, just send them in one go. Don't do some patch counting, as some people might be tempted to do, to increase their stats as a contributor. Another thing that's quite important is that each change should be functional. That's important for people who are going to investigate bugs or regressions, so they can bisect bugs and really locate when a bug or regression started to happen. So if you have one of the commits that doesn't build and prevents the execution of the test, right, you won't be able to figure out whether on what side the commit is, like whether it's good or bad, because that's what you do when you do git bisect. You start from a good situation and you have a bad situation at the end, and you split the commits in the middle and see whether the middle commit is still good or is bad. But if you can't figure out, you can't do the bisection. So that also applies to projects like the Yocto project typically. So don't introduce a change that breaks something that would be followed by the change that would repair it in another way, because that would be a broken commit. Then once you have made your changes, you can start committing your changes. So again, the nice reminder, one commit per atomic change. So if you have files that are already in the repository, you can commit them directly with git commit -s, like signature, plus the files you want to add to the commit. If you have new files, you can add them. You could actually should add them to the index. It's called staging. So stage them first by using git add, like file one, new file two, and in case you need to add specific files to the next commit that are not new files, or they are or not, you need to add them specifically with git add, right? And then you can also use git add -A to add all modified files to the next commit. And then you can commit all the added files with git commit -s, so that will capture all the added files. So you could also git commit by listing the files, of course, one by one. Once again, that's possible. The next thing to do is describe your changes properly. And I'm actually getting this piece of advice from the kernel recipes conference, which were voicing feedback from maintainers. What's quite important here is to record, not to describe the patch, which fully describe the patch while the code, if the code already does that, but give things like why the patch was created, and maybe also the consequence of not having the patch for people who may want to revert the patch for some reason because it conflicts with something, but what's the consequence of removing it? You could also mention how it was tested, and think about people or yourself studying the code, the commit in the future, like in 3 years from now, and you forgot why you made that commit. But that's why you should give the reasons, like why you did those things, and provides a background for your future self, right? On a side note, also use the present tense when you describe a change. You don't say added a new function, just add. It happens when you add, when your commit is accepted. You never know. So don't speak of the past before it actually has happened. Something else that's important too, you need to use the developer's certificate of origin, which is what you do when you use git commit -s. So you sign your commit with your name and email address, and this is part of the commit message. So this is like a hard coded in the commit. You can't modify it afterwards. So it's like a guarantee, a certificate that it was from you, at least at that time, and people won't be able to change that without changing the commit SHA-1, right? So that's a proof that you were, that kind of proof like that you were the original author, and that allows the projects to trace commits by people and see maybe that, like, if there are some commits that can be debated, or not sure about whether they were legitimate or not, like had the right license. Then you could revert some changes and trace what happened in the past and repair things if necessary. So the developer certificate of origin is some part of the kernel documentation. And then still about committing your changes, it could happen that you could have multiple changes in the same file, because that's how your things happen. You first work on implementing a solution, right? And you make it work, you debug it, you modify it multiple times until you have something that works. But then you have to figure out how to present it to the world in a nice way that can be like reviewed, and some atomic pieces that could be accepted or rejected, right? So sometimes you have like 2 changes on the same file. Oops, how do you do that? I had a problem multiple times. So there's a nice solution to this that I found. It's git add -p, which it's a partial add, or I don't remember exactly it means patch actually. But this allows you to select a specific hunks, like set of changes at a time. So typically you run git add -p. It goes over all the files that were modified, and it also goes through all the hunks, all the sections that were modified, and will ask you whether you want to include that change in the next commit or not. That's super nice. And this way you can have like multiple modifications to a file, but just stages, group the ones that you want. That's really nice here. So add the stage the hunks that you want, then commit the stage files, and go ahead and stage the next files and next hunks, and go and commit again, and so on and so on. So this is possible to have like multiple changes, but on the same file, but not commit them all at once, right? Also, the next challenge is to find a good commit title. And that's important because the commit titles are shown in the list of commits, in the release notes, in the Git web interfaces, like cgit. You see the list of commits, and readers should really figure out, without having to open the commit, what the commit is about. So should have a good idea of what the commit is about. So that's very important. And also some project will expect you to put like a keyword at the beginning to identify the modified directory, the modified subsystem. So you could read the contribution guidelines for this, but you could also just, as I do, that's the lazy solution, git log -- one line and the paths that were modified, or just the directory. And in that case, that gives you all the previous keywords that were added for the same files. So here you could go wrong with this method, but then others have made the same mistake before. So it's like less bad than if you make you're the first one to make the mistake. Another good thing to do is credit contributors. So if you just have one commit to modify, like or you could use git commit -- amend to add tags to the commit description. Well, you could do that with multiple commits as well when you edit them. So you have the reported by commit that like identifies somebody who reported the bug or notified you of the problem, right? That your commit is trying to fix. Suggested by, also a suggestion in the same way from somebody. And then you have tested by and reviewed by, that's people who have reviewed your changes or have tested your code. That's good to credit reviewers, because those people are really, really helpful for a project, for a maintainer. So that's invaluable to have reviews and tests. And then you can also CC, and that's not like a standard Git tag, as I'd say, but it's people you want to copy. You want to send a copy of your changes to. So when you send the patches, ultimately with Git send email, those people would get copied, like the maintainer of something, or yes, some people who will be interested in that particular commit and who could become a reviewer. So yes, you send more people. You send the patch to more people, and people can review and confirm or participate to the discussion. So that's great. So it's good to have those because they are added to the discussions. The next thing you want to do is to describe your branch, because ultimately when you have multiple patches, you should send a cover letter that explains your proposal and then describes, like, gives you an introduction to the commits you're going to send. In the past, I was keeping my cover letter by myself. I didn't know how to keep it in Git, so I had like my list of cover letters outside of Git, and that was really inconvenient. So now what you can do is actually store the description of your branch inside your branch with git branch -- edit description. And yeah, you just write the description of your branch. If you submit the branch for the first time, the description will be here. And then if you have another iteration of your branch, you still have that description and you can update it. So that's really convenient to keep the description in the branch. It's also advisable to start the description with a first line that's relevant, that could be used as a subject line for the cover letter. Otherwise, you have to edit the cover letter subject line by hand with the commands I will show you. If you just have a single commit, don't write a cover letter. Well, that's usually not necessary, but you could still provide some background and some more context in your commit if you want, and that can be done by using 3 dashes here, -- at the end of the commit message after the reviewed by and sign off by, right? And all the lines that are shown here, like here I'm showing some changes in V2. All this text here will be seen in the patch, will be shown on the mailing list, but won't get included in the final commit that makes it to inside the project repository. So that's great. Like, you can ask questions and add more context without polluting the final patch that would get accepted. And then you can generate patches for your branch. So if your branch didn't need a description, just git format patch and ref branch, so that would generate patches against that branch. Otherwise, yes, generate a cover letter too. And if you prepare the description, I would use a -- cover letter. Well, -- cover letter just generates a cover letter, an empty one. But if you did generate a description, did add a description to your branch, you with -- cover from description, especially if you set it to auto, it will generate that cover letter, that patch cover letter, as with the contents you specified before, including the first line as a subject line. And that's what auto does. And then you get, yes, a list of patches, like a 000 patch with containing the cover letter, and then the first change and the second change. And the cover letter too is like a summary of the changes in terms of modified files. So it's great to have one. Something important at this step before you send, now that you have the patches, review the patches, and that may help you to detect things you didn't see before, like files that you added by mistake. That can happen. Or yeah, some remaining changes that you think were not that shouldn't have been in the commits and that were still here by mistake. So when you read the patch itself, yes, it's like you catch mistakes, like maybe 30% of the mistakes before it's too late. So that, 30% of the remaining mistakes. Another need is that we have in the Yocto project is to add a specific prefix to the patch titles. So it's sometimes required for the email review to let people know what branch the patches target. So, but at the same time, you don't want to show this prefix in the final commit lists. So here's a bad example, like preparing, adding the prefix at the commit creation time. Here, that's what I was doing for a long time, and people were very polite and didn't tell me that I was like a bit had an unconventional behavior. I was doing that for the documentation patches, like putting the branch, but you can do that, but that's bad because ultimately in the patch title, you see the branch as a prefix. And when you are in a branch, you know that you are in that branch. You don't need to repeat this. So a better example, so that I eventually learned by preparing the contributor guide, was just add a regular commit title. And it's only at Git format patch time when you prepare the patch that you add a specific subject prefix that would add the branch here with a closing square bracket and an opening square bracket patch. That will generate a correct patch. So here you have the branch name before the patch, the patch keyword, and you don't have it. That's part of the email, but that's not part of the commit that would get when you run a git am to merge the patch. That doesn't show. So ultimately, you just get a normal commit for a branch. That doesn't repeat the branch name. So that's nice. Check your patches, of course, once they are produced before you send them. Some projects have tools to inspect the patches, like for coding rules, for required information, for typical mistakes. So the Linux kernel has had a great one that's called checkpatch.pl for a long time, and it's really brilliant. I don't know how I should look at the code one day to see how it actually works. So you just feed it's your patches, and it checks lots of things, lots of types of things of different types. And it's pretty good. It's pretty good checker. And the Yocto project has recently added or revived one that works great now. So it's patch test. So friends, thanks Trevor for this. You can give it, like, you can test your patches thanks to this patch test, and it will review lots of things, catch some typical mistakes, missing some information we did about patches, for example, or if you add a recipe with patches, it should have like proper tags, etc. So that's really convenient, and that opens the door to having automated review of patches that are sent to mailing lists as well. But it's better to check those by yourself before you send your patches, of course. And then you are at last ready to send the patches by email. So an important thing is to send the patches as inline attachments in the email body, not as regular attachments. And this is still linked to the way we like to review the submissions. This way, reviewers can reply to any of your patch lines. Like you can select, as if it was a regular mail, you can select one part and say, why did you do that? Or I would have done that differently, or like a normal discussion. So that's great. And only git send email, as far as I know, is the reliable way to make the received patches applicable, let's say, because other emailers would like maybe add line returns and would mangle your patches, making them unusable by the receivers. So git send email is the way to do to send your emails, because it's fail safe. Configuring git send email, by the way, if you the git send email needs to be able to send email. So either you use a local transport mail transport agents that as MSMTP, which is very easy to configure. You just like declare your SMTP credentials in a file, or you set up send mail locally. Or you can also directly configure git send email to connect to your regular SMTP server. That's even easier. So there's an example here for Google Mail that works the last time I checked. So those settings work if you can't send from your corporate email, and if you're allowed to do so, use your email Gmail account, for example. And then sending the patches. Some projects, such as the Linux kernel, have a nice command to figure out who to send the patches to. So that's script getMaintainer.pl. With you send a list of patches, and it looks like the maintenance file, and figures out who is in charge, what mailing list, what maintainers, etc. So you don't have to scratch your head. Just if something goes wrong, just blame getMaintainer. For some other projects, like our project, we don't have this yet. So you have to read the contributing the guidelines, but that would be a nice thing to have as well. And then send the patches to the expected recipients. So with --2 recipients, --CC recipients, like usually mailing lists would be CC recipients, and start sending all the patches. And then for a repository that always has the same contact address, like OpenEmbedded core. That's always you always send things like to the is that we call or we develop. I'm getting confused, but that's always the same email address. So just hard code the to address or CC address if you want to inside your Git repository, and this way you just have to say git send email and without to, and it will figure out, it will send it to the right recipients. That's really convenient. And then you will get some reviews, hopefully, and you will have to take them into account. So the reviews will make you modify your changes, maybe even change your list of commits, like the number of commits, their order, the description. You may squeeze some commits as well. So one thing you mustn't do, absolutely, is add some extra commits at the end of the branch. Like if you're super new to this, you may do that, but no, that's the way to go. Don't add bugs and to fix them. So the idea here is to rework your commits as if you were sending them for the first time once again. So if you have a branch with single commits, that's easy to modify. Just git commit -- amend, and that will just modify the commits that you mean to modify. And if you have multiple commits, the best tool I know is git rebase -i, like interactive mode rebase, and you have a list of commits in the editor, and you can reorder them, you can merge them, you can edit them, you can split them. So that's really great to edit your commits until you have what the result, the intended result. And then you can submit a new iteration to the community. Of course, update the branch information with git branch, always with git branch -- edit description to help. Yes, thanks, Slava. Yes, it's OE-core. Yes, for the OpenEmbedded core changes, right? Repository. So yes, so you edit your description, and then you should add what was changed over the previous iterations. So if you make a change, like if you make changes like those, like please record what you've modified, so that people who have already reviewed can see what you changed and don't have to read the whole thing again, right? So like that, and then you generate the patches again, and you can pass like -v3 for if that's version 3 of your series. And that will generate patches that are like v3 and then the usual patch numbers, right? And you can send them in the same way, right? You just add -v number and that's it to your regular format patch command. So what to remember at the end? The key things to remember: there should be one commit per atomic change, one branch per change set. You could use git add -p to stage specific hunks in files, like specific sections of files, not the entire files at once. Every change should work, shouldn't be broken. Make sure, of course, your changes are tested. Every one of them, again, every commit should be tested. Well, it's easier, of course, to test the end result, but at least don't intentionally add a change that would break something and that would be replaced by something else. Describes your changes well. And don't forget to use git commit.s. We still have a few contributors that are new and that overlook this. Forget to sign their commits. But now patch test is there. Check patch is there. Patch test is there. Create the contributors, because you'll get better reviews if you do. And it's also great to emphasize how useful the contributors are, and you could include them in the project statistics. And store the cover letter in the branch. That's nice, that's convenient. And use git send email as well, of course, to send your patches. That's the only way you should use. Use git commit -- amend to modify single commits. And then git rebase that -i to rework an entire branch, like all the commits in a branch. All right, I hope you at least learned a few new tricks.